Today, on how it's made. Paving asphalt. Let's get this show on the road. Marshmallow cookies. The facts behind the snacks. Loudspeakers. A product that relies on sound construction. And electronic door locks. We'll visit a factory that's no turnkey operation. Asphalt is a black liquid substance that's a byproduct of processing crude petroleum. Asphalt is a key component of waterproofing and insulation materials and roofing shingles. But its best known use is for paving roads. Asphalt cement is a byproduct of crude oil, the key ingredient they mix with crushed rocks and other minerals to make paving asphalt. So, production begins at the paving plant's quarry, where some 15 meters below ground, workers driving heavy machinery collect boulders of granite that have been blasted off the rock walls. Trucks transport the rocks to the paving plant, which is right on the quarry site. They dump their cargo into the primary crusher, a machine whose steel jaws crush these big rocks into pieces smaller than 20 centimeters. It takes mammoth force to crush solid rock. The flywheels that amplify the motor's energy weigh more than 6 metric tons. The primary crusher empties onto a mobile conveyor belt, which transports the crushed rocks to an outdoor storage area. When it's time to make the asphalt, the rocks travel via conveyor belt from the storage area to a screening building to be classified by size. There, the rocks tumble downward over a series of inclined screens whose largest holes are 10 centimeters big. What's too large to drop through goes to a secondary crusher that reduces the rocks to 10 centimeters or smaller, then sends them to a third or tertiary crusher that further reduces them to 2 centimeters or smaller. What's small enough to pass through the screens bypasses the secondary crusher and goes directly to the tertiary crusher. After this last crushing stage, the largest stones are 2 centimeters in size. Everything smaller than 5 millimeters goes in one pile. That includes stone dust created by the crushing process. Stones 10 to 14 millimeters go into another pile. Stones 5 to 10 millimeters into another. Trucks transfer material from each pile to separate compartments called feed bins. Exactly what goes into the paving asphalt depends on what's being paved, but generally, these are the 4 ingredients. Sand, stone dust, 5 to 10 millimeter stone, and 10 to 14 millimeter stone. The ingredient proportions vary according to what the paving asphalt will be used for. Stones, along with sand and stone dust as fillers, usually make up about 95% of the mix. The remainder, added later, will be liquid asphalt cement. Each bin releases a specific amount of material onto a conveyor belt running under it. The belts lead to a main collecting belt that dumps the ingredients combined onto yet another belt that leads to a dryer. The drying process, which takes about a minute, removes all traces of humidity. This will enable the materials to bond better with the asphalt cement. Screening equipment then re-separates the dried ingredients, making it possible to precisely weigh out the required amount of each one. Everything then goes into a mixer. As this demonstration shows, the mixer blends everything thoroughly. Then it's time to pump in hot asphalt cement. Oil refineries make asphalt cement from what's left over after they've processed crude oil. The paving mix contains about 5% asphalt cement. This is what happens inside the mixer. The hot asphalt cement binds the ingredients in about 30 seconds. The result is ready-to-lay paving asphalt. The mixer empties directly into trucks destined for the paving site. There, a paving machine will spread the hot asphalt on the road bed. Then, a compactor roller will pack it down. The asphalt cools and hardens in about 1 hour, depending on the weather. The next time you bite into a marshmallow cookie, you can thank the ancient Egyptians. They invented marshmallow candy by thickening honey with sap from the root of the marshmallow plant, a herb that grows in salt marshes and along large bodies of water. Modern marshmallow contains gelatin instead of sap from the mallow root. The snap test, to make sure the coating is hard and thick enough. Then, the taste test. If you've got a sweet tooth, doing quality control in the marshmallow cookie factory is your dream job. To make a batch of dough for the cookie base, they mix wheat flour, salt, baking soda and powder, cornstarch, whey powder, and potassium sorbate. Then they add several liquid ingredients. This one causes a chemical reaction, making the biscuit lighter. This cream-colored liquid is vegetable oil shortening. This transparent liquid is glucose fructose, a sweetener. The ingredient proportions are also a company secret. From the mixer, the dough goes into a machine called the chipper. It shreds the big blob into pieces about the size of the cap on a highlighter pen. This makes the dough more manageable for the next machine, called a rotary mold. Inside that machine, a large roller flattens the dough pieces, forming them into a dense sheet about 1.5 centimeters thick. It then presses the sheet against another roller, whose surface is a cookie mold. The factory uses the rotary mold machine for many different types of cookies. It simply installs the appropriate roller for the cookie in production. For marshmallow cookie bases, the mold cavities are round. The bases exit the rotary mold and make their way onto a moving baking sheet that transports them to an oven. The baking time and temperature are, once again, top secret. The baked cookie bases exit the oven and move onto a conveyor belt that transports them to a cooling area. Once they cool to room temperature, the bases go into a machine called the base feeder. It lines them up like marching soldiers to receive their marshmallow filling and chocolate coating. The process does require military precision. Factory technicians have to adjust this machine daily to ensure to-the-millimeter accuracy. A portion of filling has to land perfectly centered on each base, finishing off in a curled peak, this brand's trademark. The company won't divulge how much marshmallow filling goes into each cookie, nor will it reveal its marshmallow recipe. But marshmallow is usually made from either corn syrup or sugar and gelatin. And now for the final layer, the chocolate coating. Not only are the marshmallow and base covered in hot melted chocolate, the base floats in it, which coats the underside as well. Built-in air jets blow off the excess. The chocolate hardens inside a cooling tunnel. How long that takes and the tunnel temperature are, you guessed it, classified information. As the cookies exit the cooling tunnel, a quality control worker does spot checks to ensure the coating is thorough, hard enough, and thick enough. On the packaging line, the cookies go into plastic trays. To keep up to speed, the workers have to grab 4 cookies in each hand without breaking the coating. the trays pass through a machine that wraps them in plastic film. This keeps the cookies fresh and also prevents them from falling out of the tray. Meanwhile, another machine assembles the boxes, first folding and gluing one end shut. Once workers load the trays, the machine glues the open end closed as well. Then, with the go-ahead from quality control, the box's next stop is the cookie aisle of your local supermarket. Loudspeakers take an electrical signal and turn it into sound. The key to it all is a magnetic wire voice coil and a permanent magnet that attract and repel each other. As the coil moves back and forth, it rapidly vibrates a flexible cone. This vibrates the air in front of the speaker, creating sound waves. Loudspeakers contain at least 2 magnet and cone assemblies known as drivers. They're typically housed in a box called the speaker enclosure. To build the internal magnetic structure, the factory begins by cutting 2 plates of iron, each about 13 millimeters thick. They go one at a time onto a lathe. First, the machining tool smooths and evens out the surfaces, getting rid of the marks the saw made. Then it cuts out a small hole in the center of one plate and a larger hole in the center of the other. Next, they cut a smaller and thicker round piece of iron called the core. A reamer bores a large hole through it. They apply super high-strength epoxy glue to the core and to the back plate, the plate with the smaller hole. They glue and screw the pieces together because the bond has to be strong enough to withstand intense magnetic pull. They glue a foam filter in the hole to ensure the vibrating cone doesn't draw in dust and cause internal damage. Now they spread glue on the narrow end of what's called the metal basket, a die-cast aluminum frame that will hold the magnetic structure and cone. They screw the front plate, the plate with the bigger hole, onto the glued surface. Then they glue the underside of the front plate and one side of a ferrite, a ceramic ring made from iron powder. After adhering the ferrite to the front plate, they apply glue to the other side of the ferrite, then flip the basket over to attach the back plate. The core fits through the large hole in the front plate. They insert shims to center it while the glue dries. After screwing terminals to the basket, they put the entire structure they've just assembled into a magnetizing machine. With 600 volts of direct current, the machine creates positive and negative poles, transforming the magnetic structure into a permanent magnet, meaning it has a constant magnetic field around it. Now they wind the voice coil, the electromagnet that will interact with the permanent magnet. An electromagnet is an object that generates a magnetic field only when there's a current running through it. They wind enamel-insulated copper wire, gluing it to a rigid plastic sheet. The positive pole of this voice coil will be attracted to the negative pole of the permanent magnet. The negative poles will repel each other. The key is that the voice coil's poles are constantly reversing position because the electrical current running to the speaker is an alternating current, meaning it switches between a positive and negative charge several times per second. This makes the magnets attract and repel each other continuously, causing the voice coil to move back and forth rapidly. This vibrates the cone, which creates sound waves. After slipping the voice coil between the front plate and the core, they glue on the bottom suspension, flexible fabric rings that move with the voice coil and prevent it from rubbing on the magnetic structure. Next, they glue the cone. It's usually made of cardboard, plastic, or metal. Then they solder the electrical connections. The current coming from the amplifier travels by wire to the 2 terminals. The terminal wires connect to the voice coil wires. After making sure the cone moves freely without rubbing, they glue on a rigid cardboard cap to keep out dust. The last step is to take the speaker for an audio test drive. They connect it to a machine that transmits different frequencies. They make sure the movement of the voice coil and cone isn't obstructed in any way. Then a computer device analyzes the sound wave the driver sends out. Two-way speaker systems have two drivers in each enclosure, a woofer and a tweeter. A woofer has a large cone that vibrates more slowly for low frequencies. A tweeter has a small cone that vibrates quickly for high frequencies. Three-way systems have a third driver with a medium-sized cone for the mid-ranges. At most hotels, room keys are a thing of the past. You're more likely these days to be given a key card. When you arrive at the door to your room, you swipe or insert it to unlock the handle and get in. Because the room number doesn't appear on the card, this system is far more secure than door locks with a keyhole. The metal case that houses the door lock's mechanical and electronic components is called the housing. To make it, they begin by melting zinc ingots. To melt zinc, you have to heat it to about 390 degrees Celsius. Die casting machinery then injects the molten zinc into molds. Between injections, sprayers coat the empty mold cavities with a release agent, the industrial equivalent of greasing a baking pan. A built-in cooling system hardens the metal, then a trimming die cuts off the excess zinc around each piece and in the openings. Meanwhile, the electronic circuit board, the brain of the lock, takes shape. They call this the pick-and-place machine. It picks up the 60-odd electronic components and places them in the right position on each board. This computer-guided machine installs 15,000 components per hour. Next, the boards undergo what's called wave soldering. A mix of molten lead and tin surges up from underneath, fusing the components in place and creating electrical bonds. Then both sides of each circuit board get a coat of silicone-based sealant. This protects the components against the elements. Back to the housings now. Workers lubricate them with grease, then apply what's called a sleeve bearing, a nylon bearing that enables the handle to turn smoothly. Next comes the drive tube, onto which the lever will be assembled on the other side. There are several clutch components that link the lever to the latch. Swipe the right card and they permit the latch to retract. After applying more lubricant, they install an override that enables the hotel to open the door with a key if, for some reason, the electronics malfunction. They install the circuit board and connect it to the various parts of controls, such as the clutch motor, which they install next. Now they close up the completed housing with a steel backplate. This protects the components inside from rusting. The last step is to insert a battery pack. It holds 3 standard AA batteries. The factory tests the lock using a test key card because the lock isn't yet programmed to work with a specific card. That's done after installation. Elsewhere in the factory, they assemble the mortise, the part of the lock that goes inside the door. When you lock up, the mortise's bolt comes out of the door edge and fits into the hole of a receiving piece called the strike plate in the door frame. They close up the mortise with a back plate. This demonstration shows how they install the mortise in the door. Once it's in, they screw a decorative plate on top. This is what the finished electronic door lock looks like. Key cards have instructions on one side a magnetic data stripe on the other. They use a generic card to test every log that comes off the production line. In the quality control lab, they subject every new design to several rigorous tests. They open and close 1 million times. They subject the lever, latch, and lock to repeated impacts. They also test lock function in extreme temperatures. These electronic door locks come in several metal finishes plated over the zinc, and even in a painted finish that simulates wood. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net.
It's a wet, wild ride as the Orange County crew takes Daytona Beach by storm. Coming up next on American Chopper. Boyd faces a mutiny when some of his best guys walk out just before the deadline hits on the Corvette Stingray.
And we're in serious trouble.
Tonight, the most dangerous of ocean predators, killer squid. Sunday,